Good afternoon. My name is Jitendra Garg. I am Associate Professor at Baba Hira Singh Bhattal Institute of Engineering and Technology. Today, we will discuss the basics of pneumatic system. Let us first of all learn the various types of pneumatic symbols that are used to draw the system diagrams and for the component identification. As we can see on the screen, these are the symbols or these are the shapes and lines in the relative proportions shown make up a set of basic symbols for which circuits are constructed. As we can see here, a line or a pneumatic line which represents a pipe which is carrying the fluid, pneumatic fluid which is air, compressed air, is represented by a solid line as is shown over here. We can see in this example that a wall which is represented by this symbol, this has been shown connected to the basic pneumatic line which is represented in the form of a solid line over here. This is a pneumatic line which is used to carry compressed fluid which is compressed air in case of pneumatic systems to the various components of the circuit. Sometime in the place of a firm line, dashed line is used to represent a pipe carrying a pneumatic pressure or say compressed air. In that it is done when the pressure carrying line is acting as a pilot control line. In some cases, we can also come across a line which is shown like this. This type of say line which is normally known as a center line or a chain line in case of drawing. It is used to represent it is used to enclose a group of say devices. In some pneumatic circuits, there are a number of devices which are connected in such a manner that they are carrying out the work of a single device. And in that case, they are not doing their individual functions, but rather they are jointly doing the function of another device which is made by a combination of all these devices. In that case, a chain line is encircled around those devices to show that these devices are now integrated and they are acting as a single unit, as can be seen over here. A non-contact type of ball and a pressure regulator is being used as a single unit in this circuit. Sometimes we also come across electric lines in our pneumatic circuits, and electric line is represented by a symbol like this. The basic functional elements in a pneumatic system are represented by this, the ports are represented by triangles. These filled triangles represents the hydraulic system, whereas in case these are triangles are empty or they are not filled, they represent a pneumatic system. The size of these triangles represent the size of the port they are donating. Similarly, we also come across springs that are used as components of various pneumatic systems. A spring is shown as a zigzag line, as can be seen over here, and again the size of this zigzag line will represent the size of the spring that is being used at that particular place in the pneumatic circuit. Sometimes we also come across a slant arrow as shown over here. These slant arrows are say overlapped onto the pneumatic symbols to show that very component which is being overlapped by this type of arrow is say a replacement. It is an adjustable commodity which can be adjusted depending upon the need. So, here we can see that an arrow has been overlapped on the piston of this cylinder, and it shows that this particular piston is an adjustable type of piston which can be adjusted to give say end cushioning to this particular piston. We usually come across these type of arrows in a pneumatic circuit. These arrows are used to show the direction of flow of fluid that the fluid will follow when the particular circuit in position. As in case of this wall, we can see there are a number of arrows which has been put on into this wall, and it shows that when this particular block is in position of the wall, then the fluid will flow from this port from here in this direction, and the fluid from this port will flow in this direction. And when we push this button, then instead of this block, this particular block will become functioning, and in that case the fluid from this port, which will be shifted to this position, will flow from here to here, and the fluid from this port will flow from here to here. We also sometimes come across T type of symbols in the same type of pneumatic circuits, as can be seen over here. These symbols represents that though the ports which are being guarded by these type of symbols, they are closed ports. It means no fluid is going to flow in any direction from these ports, or they are closed. We also come across these type of symbols. These are restrictions. It shows that the wall or the pipe from where the fluid is flowing, and which is marked by this type of symbol, it is a restriction which is causing the fluid to move through this restriction. And in case it is guarded by an arrow, slant arrow, it shows that this particular combination is an adjustable flow control valve. These are some of the symbols that are also seen in the case of pneumatic circuits. They are simply used to represent the clockwise and anti-clockwise motion of shafts. Say, we can see here that this particular symbol which is overlapping the shaft, it represents that this shaft will rotate in clockwise direction, whereas in case a symbol instead of this is placed onto the shaft, it shows that the shaft will now rotate in the anti-clockwise direction. Whereas a symbol which is like this, if this is overlapped on a shaft, it shows that the shaft will is in a position to rotate either in clockwise direction or in anti-clockwise direction. The valve seat is sometimes represented, or most of the time it is represented by a symbol like this. If we come across a symbol like this into a pneumatic circuit, it shows that at that particular place in the circuit there is a device which is used to measure the temperature of that particular point in the circuit. If we come across a symbol like this, it denotes that this particular device is a prime mover, such as an electric motor or a generator or whatever type of power source which is used to give power to that circuit. These are the connections that are used. These type of symbols are used to denote the various type of connections between the pipes. If we are having a symbol like this, it shows that onto this main line another pipe has been joined, so that now this particular junction or this particular direction or this particular branch is also taking pressure from the main line. And please note that there should be an arrow, a pointer which is marked over here. It represents that these two lines are connected. Similarly, here in this junction, we can see that onto the main line two taps has been taken out, but in this figure we can see that all the two lines are crossing each other, but there is no dot at the junction point. It represents that these are two individual lines which are just crossing each other, and they are not connected otherwise. It means the fluid which is flowing in this line and this line, they are separate entities and they will not get intermixed. This type of symbol is used to show the flexible lines. This type of symbol shows a continuous air bleed system, and this type of symbol shows an temporary air bleed system. This symbol shows an air exhaust system. In pneumatic circuits, the power production unit is a pump, and that pump is being powered by a prime mover, and this particular combination is used to compress the air which is stored in some sort of accumulator that is to be used later in the circuit. As we can see here, a pump and a prime mover combination is shown like this, and an air receiver or an accumulator where the compressed air is stored temporarily for later use is shown like this. And valve, an isolating valve, is represented like this. The function of an isolating valve is to regulate the supply of compressed fluid from the accumulator. It is used as a shutdown valve or a cut-off valve, so that we can take off compressed fluid from the accumulator whenever we require, and otherwise this remains closed. The actuators are the main components or the basic muscles which are actually working in that pneumatic circuit. They are the devices where compressed fluid is provided to these devices, and they actually convert the power of that particular fluid into the mechanical motion that has to be used in that particular pneumatic circuit. Then again, the most commonly we use the cylinders as cylinder and piston with cylinder and piston arrangements in them as an actuator in a pneumatic circuit. These cylinders can be single acting cylinders, as can be seen over here, or a double acting cylinder which is shown over here. These are represented by a symbol like this. A single acting cylinder is shown by a symbol like this, where this particular port is connected to the compressed air and is evacuated back, but this particular port remain unguarded. However, in this type of double acting cylinder, both these ports can be used for input of air as well as the exhaust of air. This is the symbol for a single acting cylinder with spring in stroke, and this is the symbol of a single acting cylinder with spring outstroke. This is as I have already discussed, this is a symbol for a double acting adjustable cushioning cylinder, and it is a single double acting through rod cylinder, which is shown over here. Now, let us come to the direction control valve, which are the most important components of a pneumatic system. A valve is represented by a pair of numerics separated by a slash, as can for the example is 3/2 direction control valve. The first numeric in this representation represents the number of ports that are there in that particular valve. As in this description, we can say that this particular valve, which is represented by a 3/2 direction control valve, this is having 3 ports, and there are 2 positions that this valve can take. Let us further elaborate this example of this 3/2 direction control valve. These are the individual say positions of this 3/2 direction control valve. We can see here that there are 3 openings or ports which are there in this valve. One is this, second is this, and the third one is over here. So, now there are 3 openings, and these 3 openings can be moved in such a manner that there becomes 2 positions. One is this normal position. When this is not, the valve is not actuated, the port position is like this. It means this particular port will be connected to this particular port, and this particular port is closed. But when this valve becomes operated or it becomes functioning, in that case this port is connected to the upper particular port, and this particular port is closed. In the diagram or the representation of a valve, both these positions are combined like this. Further, these 2 type of symbols are also attached to this particular symbol, which represent that this particular system, this particular opening is connected to a vent or exhaust system, and whereas this is the inlet from where the compressed air will be coming. In addition to these things, these 2 type of symbols are also joined in case of a valve. This particular symbol represents the manner in which this particular valve is going to be operated. This represents the method by which this is going to be functional. In this case, this type of symbol shows that this valve is going to be operated with a push button system. It means in case we push this system, the whole block will get shifted here, and so that the actuated position will become functional, and the valve will behave as is shown in the second position of this valve. And this spring actuated shows that how this particular valve is going to come back after it has been actuated and after the actuation pressure has been released. So, this spring shows that the return of this particular valve is by means of a spring action. As we can see here, when we push this button, the position of this valve become like this. We can see here that now this particular port is connected to this port. It means this particular port is connected to the exhaust, whereas the input port is closed. But when we actuate this, now the input port is connected to this particular port, whereas the second port, this particular port which was earlier connected to this port, has been connected to the exhaust. Now, these particular ports, we are talking about these port, that port, because we have not named them. Now, let us see how they are named. This is the usual manner in which these ports are named. This is port 1, this is port 2, and this is port 3. Now, it is more easy to elaborate that in this particular position, port 1 is connected to port 2 is connected to port 3, which is in turn connected to the exhaust of the system, whereas port 1, which is connected to the inlet of the system, remains closed. And when this second block will become functioning, in that case port 1 will get connected to 2, so that the pressurized fluid or the working fluid will now start entering the port 2, whereas the port number 3 will now be connected to the exhaust. Let us now see the example of use of this type of valve to actuate a actual cylinder. We can see here that the same type of symbol as we have earlier elaborated is being used. In this circuit, we can say that a valve has been connected over here, which will control the flow of fluid from this is the inlet line and this is the exhaust line. This particular valve controls the flow of inlet line and the exhaust line into and out of this particular piston system. Now, at this particular position, this is the unactuated or normal position of the this system or this valve. In this position, no pressurized fluid is entering the cylinder, because this line or the port from where the pressurized fluid is entering, this is closed, whereas this particular chamber of this whole piston system, this has been connected to the exhaust port. So, in this particular position, this because of the spring action, the piston will move in this direction, so as to complete a stroke like this, so that the air which has been enclosed in this chamber, that will be exhausted through this valve. When we press this button to actuate this valve, in that case the whole block will get shifted like this. Now, this port number 1, which is getting or which is receiving the pressurized fluid, is connected to port number 2, which in turn is connected to the inlet port of the cylinder. So, now the pressurized fluid is entering to this cavity of the piston, which is causing the piston to move in this direction, and whereas the output port is not connected to anything, or it is connected to port number 3, but it is closed. The same thing we can learn for a 5/2 direction control valve. Instead of having 3 ports, in this type of valve we are having 5 ports, 1, 2, 3, 4 and 5. Similarly, these are the 2 positions of this particular 5/2 direction control valve. This is the complete picture of a completed 5/2 direction control valve. It shows that the middle port, this is connected to the inlet, whereas these 2 ports, they are connected to the exhaust, and these are 2 operational ports which are shown over here. When we push this button, this whole system will become operating, and as a result of this particular block gets shifted to this direction. Now, this particular port is connected to exhaust, and this particular port is getting the pressurized fluid. The port markings can also be done in this case, or so if we mark this pressurized port as port 1, this operational port 2 as this as port 2, the exhaust port this as 3 and 4 and 5. Now, in this particular position of the this valve, port number 1, which is the getting the pressurized fluid or the input port, this is connected to port number 2 of the circuit, and port number 4 is connected to port number 5, which is in turn connected to the exhaust. So, port number 4 is connected to the exhaust, and the port number 3 remains closed. Let us see how this particular valve is used to control a 2 directional or double acting piston cylinder arrangement. Now, in a double acting piston cylinder arrangement, there are 2 openings in a piston. One is connected to one end of this whole cavity, which is divided into 2 portions because of the movement of this piston, and the other one is provided at the extreme end of the this cavity at the other side. So, now in this particular position, when this valve is not operational or it is in normal position of this valve, then now this port number 1 is connected to port number 2. It, as we can see from this symbol, since this port number 1 is getting the pressurized fluid from in this direction. So, in turn this port number 2 is now getting the pressurized fluid and the piston is getting shifted to this direction, because in this particular position the air is entering this cavity from this direction, and as a result of the force of that pressurized air, the piston moves in this direction. Whereas the air which has already been trapped in this particular cavity because of the earlier action of the cylinder piston arrangement, that has to be evacuated properly, so that the piston can move in this direction. Otherwise, will not be possible for the piston to move to the extreme position in this cylinder piston arrangement. For doing that, this particular port which is at this end of the cavity, this has been connected to exhaust through port number 4 and 5. When we push this button to make the second position functional, now the system is reversed. Now, instead of connecting this port to the input line of the system, we are connecting the 1 number port is connected to now the 4 number port, which in turn is connected to the left side of this piston, and the port number 2, which is connected to the right side of the piston, this is now connected to the exhaust. So, in this particular arrangement, the pressurized fluid will rush into this cavity in this side, and this particular side of the cavity is now connected to the exhaust. So, because of this arrangement, now the piston will move from here to here, and when again we release this particular button, because of this spring action, it will again come back to this position, and as a result the air will again start entering this cavity and will be evacuated out from this cavity, and as a result the piston will move in this direction. So, using this valve we can operate the double acting cylinder or this two-way acting cylinder piston arrangement, so as to get a mechanical movement at the end of this rod. Now, these are the various types of operators. Operators means the various methods by which we can actuate the valve or deactivate the valve. The normal symbols that are used to represent the various type of actuation system are represented over here. A general manual type of system is represented like this. A push button type of system that we discussed in our previous slides is represented like this. A pull type of system is represented like this. A push and pull type of system where there is no spring at the back of this valve is represented like this. In this type of system, when we push this button, the whole arrangement of the whole, in case it is a direction control valve and the two-way direction control valve, then it will get shifted to the second position of the valve, and when we pull this button, then it will again shift back to the normal operating position of the valve. We can also use a lever in case it is a larger valve. We can use a paddle for in case we require to apply much more force to operate this particular valve. We sometime also use a threadle system for operating this valve, and the rotary knob can also be used, which is represented like this. There can be some mechanical arrangements also, which is used for operating and returning back of this particular type of valves. This is a plunger type of arrangement, as can be seen over here. The second one we can have already seen. This is a spring arrangement, which is normally used for the return back of the valves to the normal position, and a roller is also used. This unidirectional system we can also use sometime. Sometime in addition to these mechanical systems and in addition to the manual systems, we also use air in turn for operating the valves. In this system, we will represent the system like this. So, now there will, in case a pressurized fluid or air pressure is applied at this end of the valve, only then this valve will get operational, and this is the this type of system is known as a pilot pressure type of operating system, and this line which is used to show the pilot line is shown as a dashed line. This is the pilot pressure system. This is a differential pressure system. Differential pressure system is used to operate systems where we want to apply some sort of logic, so that now this particular valve will operate in this direction in case the pressure at this end is larger than the pressure at this end. In that case, the movement of the piston or the whole valve will be in this direction, and this portion, this right portion will become operational. And in case the pressure in this direction is more than the pressure on the other direction, then the movement of the wall will be in the reverse direction. In addition, we can also use some electric system or solenoidal system in addition to the mechanical system, pneumatic system, or whatever we have discussed earlier. A solenoidal system has a electric system or an electromagnet connected to the main shaft of the wall. So, that when we supply electricity to this solenoid, it becomes operational and it pulls the wall in one direction, and as soon as the electricity which is passing through this solenoid ceases to pass through the solenoid, the magnet get removed, and as a result of magnetic effect being removed, it the wall return back to its original position because of the inbuilt springs in that system. These are the diagrammatic representing of various types of operating systems or operators that are used for operating the walls. This is a push buttons type of system. This is shrouded button. This is mushroom button. This is twist type of knob. The switch, emergency stop, key release system, where a key is used. Until and unless we insert a key into this system, we cannot operate this wall. This key pointer, plunger type of system, roller type of system, one way tip, air pilot trip, solenoidal pilot valve. These are some of the arrangements. Now, let us have a glance on the various type of valves that are actually used in the system and see how they work. These are some of the valves. As we can see here, this is a push type of push button type of valve which is being represented over here. This particular type of system is known as a roller operated valve. This in fact is very useful in the pneumatic systems which are used to make an automatic system. So, that whenever there is this movement and in this direction of another piston type of arrangement, it in turn causes this valve to operate, which in turn causes movement of that particular type of piston to be reversed or so on, and a complete pneumatic circuit is built up. These are some other type of valves which are say spool type of valve or other type of valves that we will discuss in the remainder part of this lecture. And furthermore, some other type of valves are here shown here. This is a typical cut out section of a solenoidal valve. We can see here there are some ports and there is a solenoid which is connected to the central spool of this particular type of valve. So, that when some electricity is applied to this particular solenoid, it pulls this whole plunger in this direction, as a result of which the connection in the ports is reversed, and as soon as the electricity is cut off because of the spring which is present over here, the plunger get moved in this direction and the valve arrangement gets reversed. We also sometimes come across the poppet valves. This type of this diagram represents a 2 by 2 poppet valve. We can see this type of poppet valve is governed, or this is connected to two ports. One is this one and the second one is this one. This darker blue color shows that this particular opening is connected to the pressurized fluid, whereas this bit lighter color shows that the fluid over here is at a lesser pressure, or in turn we can say that this is connected to the vent or lower pressure side of the system, whereas this particular side is connected to the higher pressure side or the input line of the system. Now, this particular seat can be moved up and down, and there is a spring which causes the say reverses the motion of this particular seat. We can apply some pressure over here. This can be applied either mechanically or using some pilot pressure, as a result of which this whole system will be moved to downward direction. In that case, these two ports will get connected, and this port number 2 will also get the pressurized fluid which is coming from this direction to this direction. And as soon as this pressure is cut off because of this section, this spring which is shown by these red dots, because of the presence of this spring, it will, this poppet will zoom back to its initial position, thereby sealing this particular seat, as a result of which this the connection between these two ports will be cut down. We can see the operation over here. As soon as we apply the pressure at that particular end, the poppet goes down, and as a result of which these two ports gets connected, and as soon as the pressure ceases to be applied at this position, it return back to its position and this valve become closed. We can see this action. This is how this 2 by 2